Hey everybody, it's Alex from Engineering Applied. We're going to be accelerating your career, hobby, or business with this overview of the available Derive function found in Autodesk Inventor. If you want more easy to understand and practical content made by an experienced engineer like myself, make sure you like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. If you're looking for a specific function, check the description for timestamps, and if you don't find what you're looking for in this video, check out my other videos in the Autodesk Inventor series playlist because I'm confident you'll find exactly what you're looking for. Let's get started. Okay, everybody, so to help illustrate the Derive command and its uses, I have a threaded standoff design and then two derivations of that design shown on screen. Now, what you see here on the left is the off-the-shelf hardware that I sourced from just some arbitrary vendor, it doesn't matter. And the whole objective of this practical example is to simulate a scenario in which it's less expensive in our design to take an off-the-shelf piece of hardware, so in this example, it's a threaded standoff, and then grind the height of this top portion down to suit our design needs in our particular assemblies that we're putting together. So these are actually part of this original part, but this is a simulated scenario in which we cut this height down to 1/4 of an inch here, and then 3/16 to accommodate our various designs. Now, what you'll encounter sometimes when whether you're designing a product or sourcing components maybe for a project of yours, oftentimes it's less expensive to source off-the-shelf parts and modify those rather than going to a vendor and ordering custom-made parts for your one-off design or maybe for a production run. Now, this is something that's pretty common in the product development field. So if you're familiar with that, you'll know exactly what I'm talking about. If not, I hope this is something new that you pick up from the video in addition to the Derive tool. Now, to get started here, we're going to open a new part file and I'll show you how to take an original part. So again, in this case, it's an off-the-shelf part, and derive various designs based off of that parent geometry. So what we're going to do here is we're going to just start a new part, and we'll go up to the create section and we'll go to derive. So we'll go up to derive here, and let's go ahead and let's pick up this threaded standoff off-the-shelf part. So this is what I downloaded from, in this case, I downloaded this from McMaster Car. So a lot of you might be using this website or this distributor to source your parts. It's pretty common for that. So this is what we get when we click Derive Part and we picked our parent file. So along the top here, we see Derive Style, and we get a few different options here along the top. The first option is single solid body merging out seams between planar faces. So if we want to eliminate the seams between various solids, on our Derive part, we could use that. Here, this preserves the seams between our solid bodies, or our planar faces rather. And then here, and this is the current option that's selected, is maintain each solid as a solid body. So in this case, I downloaded this parent file as a step file, and in that file, we have a single solid body. So everything that you see here, the threads, all of these planar faces, this is all closed geometry as a single solid body. So in this case, this is what we want to use because we want to maintain that relationship with the original parent geometry. And then this final option here is the body as work surface. So if we click that, it converts all of this into a work surface if you want to import it as a series of surfaces for whatever reason. Okay, we go down to the status section. So you have a plus and a sort of like a dash here. So when we select various parts in this window here, so in this case, we just have the single solid body that we can import. Well, we can control what we're actually deriving from by clicking these little plus or these little dashes here. So in this case, for example, if I wanted to just not select a solid body, I could click that and it changes to a dash, and then it eliminates that from the model tree here. Now, just keep in mind, in this particular case, the only geometry that we do have is the solid body. So by clicking this, it wouldn't derive anything. So we'll actually undo that. And you can also toggle those by selecting the name on the section itself, and then going up to this little status bar, and then you can click the dash or the plus. Okay, moving over, we have the little opens the base component to allow object selections arrow button. So essentially what this does is it allows us to select various objects individually in our part that we've loaded in. So if you need to do that, that's available to you. And then that just applies those selections that you've made. Okay, moving down, we have our show all objects button. So you can uncheck that if you only want to show the exported geometry. Moving down, we have the use color override from source component. So essentially, if your source part that you have is, let's say, blue or whatever other color that you assign to it, if you leave this checked, it will import that source color from the parent part. If you want it to be completely independent as far as the color goes, you can uncheck that. I'll leave that checked. Here we have our sheet metal styles and our reduced memory mode. Moving down, we can select our design views, our scale factor, so we can actually rescale this. So say if I wanted it 2 times scale for whatever reason, we could do that. But in this case, we just want to leave it as the default of 1. We can mirror the part as well. So we can mirror it over various planes. So let's say we want to mirror this part over the YZ plane. We could select that and it'll just sort of flip that part around that plane. But in this case, we don't really want to mirror it. So we can uncheck that. And here we'll click OK. So when we click OK, it brings in the derived part. Now, if we look at our model tree here, we see the original part. And this is pretty neat because we can actually double click on this and it'll open that parent part file separately. So we could make changes in there if we want to. You'll notice that I have the material set as aluminum 6061 because in this case, I want to use it in an electrical enclosure and I want a non-magnetic piece of hardware in here, let's say, for example. So I'll just close out of that. We'll go back into our original part. Now, let's get to modifying this to create some custom parts. So in my example that I showed you previously, I had 2 different iterations of this where the step size was smaller. So what we can do here is we'll go ahead and just create a sketch on this top plane because we want to actually simulate that we're grinding this or cutting it shorter so it fits in, let's say, an enclosure that we're designing. So we can go to new sketch here, and I'm just going to select that plane. And I'll just project some geometry. I'm doing this because I want it to reference these outside faces on this part. So I'll just go ahead and pick these up real quick. Okay, so we have all of our edge geometry projected from these faces that I picked up here. And again, this is to execute our extrude command to where we're going to cut down the height of this. So we'll just go to finish sketch, click extrude, do our cut Boolean operation. And I'm going to take it down to a distance of 0.1875 from this top face so that we end up with a total height of this step at 0.250. So we'll click OK. And there we go. That's how we use the Derive tool to create modified geometry. And in this example, this was used to take an off-the-shelf piece of hardware, modify it for our particular use case. And a lot of times this can be a more economical method than creating a completely custom part from scratch. That concludes this segment of the Autodesk Inventor part creation module, where we took a look at the available Derive command. Don't forget to like this video, subscribe to my channel, and turn on notifications to stay up to date on future content that will help you reach your goals along your journey. And of course, don't hesitate to leave a comment or reach out via my website contact page and let me know if there's anything else you'd like to learn about or see on this channel. Thanks again for learning with Engineering Applied, and I'll see you again soon.